We were right in the middle of 2C on the Chapter 8 practice test. We had done the first step, so we wrote our nested parentheses, so keeping it in the same order, g of f of negative 2. And we know from order of operations, you always do what's inside first. So we need to do f of negative 2 first. So I went down here. Everywhere I saw an x and f, I replaced it with negative 2. And because it was negative, I had to put them both in parentheses. So negative 2 squared plus negative 2. And they are in parentheses, so negative 2 times negative 2 is 4, plus a negative is minus 2. So we found f of negative 2 to be 2. So now what we do is we go up here and go, oh, so I can replace f of negative 2 with 2. So to find my final answer, the answer for the problem, I'm really just evaluating g at 2. So now I go into g. Wherever I see an x, I plug in a 2. So 3 times 2 minus 1. 6 minus 1 is 5. So I know that g of f of negative 2 is just 5. So the final answer is the answer to the problem. That's why we call it a composition, because we take the answer to the inside and we plug it into the outside function to get the composition of the two. So the answer of the first is then plugged into the outside, and that is the answer for our problem. So those are really easy after you practice a couple of them. Okay, next we have inverse. This is a big one for the next class. You do a lot with this. So for inverse, remember the symbol means f is read f inverse of x. So sometimes they use the words, sometimes they use a symbol, so you should be able to recognize these directions with either one of these. And hopefully you remember from the beginning of the chapter, remember how we learned exponentials and logs are inverses. How you get an inverse is by interchanging your x and y. So step 1 is we need to have a y. So step 1 is always to replace your f of x with y because they're the same thing. Step 2, because we're finding the inverse, that means x and y need to be interchanged. So the y becomes an x, the x becomes a y. Step 3 is to solve for y, because we always want it to look like y equals mx plus b. So since I'm solving for y, I'm going to flip the equation over, because I like to have the equation I'm solving for, or the variable that I'm solving for on my left side. So to get y alone, I have to do the opposite and move everything else over to the other side. So I get 5y equals x plus 7. And finally, my last step to get y alone is to divide both sides by 5. So I get y equals x plus 7 over 5. So step 1, make the f of x a y. Step 2, interchange x and y. Step 3 is solve for y. And then the last step is tell the reader what you found. Oh, what I found is f inverse of x is x plus 7 over 5. And that is my answer. And that shows the reader that's the inverse of our original function. And you can see this one's minus 7, this is plus 7, this is times 5, this one's divided by 5, so they are inverse operations. So it's kind of hard to see there, but let's go ahead and box that answer to make sure everybody knows that's the final answer. So then last you label it to show everyone that you have found the inverse. Okay, next we start the logs. Yay! So this should probably be the freshest in your head because we've just done this recently. So this first one wants us to write in exponential form. So this is just a simple loop and swoop. So 5 to the third, because remember the base of the log becomes the base of the exponential. Since a log is just an exponent, we know that has to be the exponent, plus the arrow tells us to write that next, and then we set it equal to the argument. And then, as I said when we were learning this, you can always verify that you've done it correctly on ones like this because it makes a true statement. 5 cubed is 125, so I can walk away and go, yeah, no, I got that one right. Okay, now this one wants us to just do the opposite. So this was called taking a log and writing it as an exponent. Now they have an exponential and they want us to write it as a log. But really, this isn't quite an exponential yet. Didn't we learn this is the same thing as this? Because in order to change it into log form, you need it to be an exponential first. So you need it to look like this. So, because students go, well, I would never even know to do that. Well, exponentials and logs are inverses. So if you're changing an exponential or a log to an exponent, you can see an exponential expression needs an exponent. That one didn't have an exponent, so that's how I knew to do that. And then you can do loop and swoop with this too. So to put it back into log form, remember the base of my exponent becomes the base of the log, so write the 36 down low. Then the next number I write is 6, so 6 is going to be the argument, and I always know I'm going to set it equal to the exponent because a log is just an exponent. So this is just the order, right? Your 36 first, and it has to be the base. Your 6 is the next number you write, and it should be even with the log. And then you always set the log equal to the exponent because a log is an exponent. And then you can do your loop and swoop and make sure you get back there. 36 to the 1/2 equals 6. Yep, I get back to that. So that's how you can verify. So you should be able to go from exponential to log form and from log form to exponential form. Oops, I said that backwards. Log form to exponential form and exponential to log. You should be able to go both ways. Okay, let's look at our next page. So next we're going to graph each of these. And I'm having you put them on the same graph. On the test, you won't have them on the same graph. You'll have them on two separate. But it's kind of neat to see the inverses on the same graph so you can see how they're mirror images about the line y equals x. So I just did it for fun. But on a test, this will be one problem. And on the final, this is your last two questions on the final exam, by the way. Number 40 and 41, or 39 and 40, I can't remember, but yes, they're on the final two. So, but they'll be two separate. They'll be graph this, its own t-table, its own graph, and then it'll be graph this, its own t-table, its own graph. But since they're exponentials, the exponential and log are inverses, I just wanted to put them on the same graph so we could see that. So let's do the first one. So this would be y equals 3 to the x. They're telling us what each of the x's are. So this first one would be 3 to the negative 2. I shouldn't have written that there, huh? It's kind of in my way now. Well, I guess I'll write it underneath. So 3 to the negative 2 goes there. 3 to the negative 1 goes here. 3 to the 0th, 3 to the 1st, 3 to the 2nd, 3 to the 3rd. So those are plugging in each of these numbers for x. So we know 3 to the negative 2 means 1 over 3 squared, which means 1 over 9. And 3 to the negative 1 is 1 over 3 to the first. And I remember when I was doing this on Alex, they want fractions. They don't want decimals. So don't plug this into your calculator. You should be able to do this in your head like I'm doing. 3 to the 0th, anything to the 0th we learned is 1. 3 to the first is 3. 3 to the second is 9. And 3 times 3 times 3 is 27. So we're not going to be able to use that point, but they asked us to find it, so we're going to find it. Okay, so exponentials. Do you remember how they had a horizontal asymptote? And this one hasn't been moved left, right, up, or down. There's no number added or subtracted from it. So that means it's going to have the typical asymptote, which in this case is y equals 0. So horizontal lines are always y equal because they go through just the y-axis. Well, this one lies on the x, but most horizontal lines only go through the y-axis. So they're called y equals, and let's label our axes too. Okay. And I do ask you to state the domain and range, and I do ask you to graph it and put in the asymptote. So we're ready to graph. So negative 2 goes with 1/9, and if you don't know what 1/9 is, it's 0.11111. Any number over 9 just repeats. So 2 9ths is 0.22222, 3 9ths 0.322, 4 9ths 0.44. So I know this is about 0.1. So x is negative 2, and about 0.1 would be right above it. X is negative 1. And a little bit higher at 1/3, 0, 1, which we learned is on every exponential graph. 1, 3, 1, 2, 3, and 2, 9. It's going to be our last one. And so now we're ready to graph. And we always put our asymptote in first. Do you remember why? Because it's our graphing aid. And we need the graphing aid because we have to know don't cross the x-axis. Don't touch the x-axis. Just go right along beside it. So let's draw this part first. And don't forget to put arrows. And then we need to draw the second part and just have it crawl right along its asymptote. So this one is f of x equals 3 to the x. And we are supposed to always label graphs if they have, if you're going to have more than one on a graph. So that's called the exponential graph. And because the base is greater than 1, it's called an increasing function because it rises from left to right. So let's go ahead and do the domain. So domain, remember, is left to right because it's the axis. The leftmost value is going to be negative infinity. And the rightmost value, it's going to go right forever. See that arrow? So it's just going to keep going further and further and further right. So it'll be positive infinity. The range, not the same. Because if you look down here, there's no y values down here. So the lowest y value is right above 0. So remember how we said it can't touch the x-axis? That means y can never be 0. But it can be everything above there. So 0, bottom to top, infinity. So range is always bottom to top. Okay. Excuse me. So we only have about 15 seconds, so I'll go ahead and start the second part of it on the next video.